she is an assistant professor in the Department of Human Design and Engineering at the University of Washington, where she directs the Machine Agency. And her work is focused on unconventional digital fabrication tools, small-scale automation, network controls, advanced manufacturing, the hard stuff. She was also named this year, congratulations, Nadya, one of the MIT Technology Review Innovators Under 35. There's no higher praise than that. So, you've done splendidly. Before she was at the MIT Center of Bits and Atoms, she's the vice president of Open Hardware Association. I shouldn't speak so fast. And she is going to present to us some thoughts on creative automation, the future of work, and how we work together with robots and system integration. Well, I'm not going to talk more about that. I'm giving the floor to Nadya.
I'm going to talk to you guys about creative automation. And I mean, in my research group, Machine Agency, I'm mostly interested in how to harness the precision of machines for the creativity of individuals. So not mass production or really large-scale automation, but being able to take advantage of computer control to be able to do small-scale things like making drawings that you want, or winding coils that you need, or other kinds of fabrication tasks. And here are some of the machines that I've made in the past and I have presented before at ThingsCon. But lately I've been thinking a lot more about scientific exploration and how people explore in the scientific realm. And science really is based on questions like, what grows at the bottom of this pond? Or what can you feed this yeast to make it grow faster? What happens when I add these things to each other? And one of the things that's maybe a drawback of science is that it's really results driven. It's like you need to have the answers to those questions. And to get those answers, you do experiments. But sometimes how you do those experiments is just by any means necessary. You need to have whatever it takes just to get the data, and then you publish the data. And right now, science has a reproducibility crisis. So it's really actually hard to replicate other people's experiments. And I think that the precision of machines really can play a role there of understanding how to run experiments in a really different way, such that not only are they replicable by others, but also it helps you answer these questions and also ask new kinds of questions. And so a lot of the systems that I've been building are addressing this. Like, how can we, instead of just being results driven in scientific exploration, also be infrastructure driven, or understand how we can harness automation for this kind of experimentation. And so the way that I approach it is through modular machines. Now, previously, robotics was mostly used for dull, dirty, and dangerous tasks. And part of the reason for that is it's really difficult to start out with robotics. You have to invest in a system, and then they're tedious to program, and it's not necessarily easy to customize it to do whatever you want. And it often requires specialized technicians to run. And so that's not actually feasible for, especially if you're specialized in something else like plant science. You can't also become a roboticist just to be able to do your experiments. And so what does it take for automation to be a creative tool? How can you have systems that are playful and modular and reconfigurable that allow this harnessing of the precision of machines, but without you having to, get a PhD in robotics to run it? So the systems that I build are all with the idea that you should be able to extend and customize them for different applications. So for example, taking advantage of digital fabrication like 3D printing to make the machines and use off-the-shelf hardware and parts that you can make locally in low volume instead of having to rely on specialized supply chains. And designing things like interchangeable heads so that you can start doing different kinds of tasks on the system. This is a tool changing machine called Jubilee, and it can pick up different things. So you can sonicate or image all in one workflow. And I think for a lot of machine manufacturers, they'll say, 3D printing is not a very robust technology. You should be casting this out of iron and making granite bases. But I think that the thing that you need to take advantage of is design patterns that actually enable precision. So error correcting geometries, like this is a Maxwell coupling, so that I can pick up and drop off this microscope thousands of times and never have it move position more than a couple micrometers. Or be able to take advantage of flexures so that I preload different systems so that they end up in the same place all the time. And that kind of design pattern, I think, lets you use low precision manufacturing to still get really precise hardware systems. And I think that the way that you can really extend them is by making these kinds of systems open source. So it's not just that I made this coupling, but that this coupling becomes a template, like an API. So I can now design just the tool that I want to use. So instead of a microscope, maybe I want to use a little mixer or something. I only design the tool, and I can then interface with the rest of the system rather than having to design a whole machine from scratch. And I think a lot of the times when you talk about robotics, part of what falls by the wayside is the interfaces and the software that you use for controlling these machines. And it's sort of like a default state to think that all of these systems have to be like weird encrypted DLLs that run only on computers that you have special licenses for. By now we globally are pretty good at software. So why are the interfaces to these machines not application specific? Why don't they take end user programming into account? And so if I want to have a machine that's in a chemical engineering lab, why should that machine have the same interface as a machine in an advanced manufacturing lab? And so how can we make these interfaces to the machines customizable and show transparency of what the machine is doing and how? And then finally, I think you can start, if you do a lot of modular systems and you have wide system integration, then you can start doing really clever stuff, like designing feedback loops. Like here is this duckweed that I can photograph and determine what the area is. And based on the area of the duckweed, I can then change the amount of growth media that I want to add. Or I can pick up the ones that look promising and do different things with them. So it's not just automation of rote tasks like dropping liquid in, but it's also the automation or the smart parts where you can take measurements and design feedback loops. And right now, I think a lot of times scientists are the feedback loop. And instead, how can you have that part be something that you can program in so you can rely on your machine to do that for you, and you can focus on creative problem solving. And so I guess in this Ask Me Anything, one of the things that I think is often the kind of thing that we talk about with automation is jobs lost, or there's a lack of trained workers to engage with automation. And I think, this is a real problem where there is not, maybe more so in the United States than in the Netherlands, but where there's not necessarily a career path going from, for example, technician jobs or manufacturing jobs to working in automation programming. And I guess a lot of the time people say it's this lack of trained workers. Like we need to educate the workforce to be able to engage with these systems. But I also think that it's the systems themselves. And so one of the things that I think is lacking is, why is this technology so inflexible? Why is it so unintuitive? And if we can design automation systems such that they can be harnessed in lots of different ways by lots of different and diverse groups, then can it be the opposite? Instead of us trying to keep up with automation, that automation becomes a creative tool for all of us. So yeah, I don't know. I can also talk about other stuff if you guys like, but that is what's been on my mind lately.
Well, yes, we want to speak more about other stuff, but let's first dive into this particular topic. So, and audience out there, ask me anything means you have to ask questions. But I'll start. I'll make it easy for you guys. What you describe sounds well, very logical in a way. I mean, once you understand the concepts, you think like, oh yeah, okay, I understand. This could really work. And you are your team and lab developing this, but is there a sort of a global network of people that work on this kind of machine building? Is this a very specific local thing?
I think that definitely this has grown, or my work on machine building has definitely grown out of the broader maker movement. And a lot of the things that I show are enabled by the maker movement. Like 3D printing 10 years ago was still extremely expensive. During the pandemic, I am teaching digital fabrication remotely to master's students, and they can't come into the lab and use 3D printers, but they're so cheap now that I had each of them get their own. So everyone their own 3D printer in their house, because they're less than $200 now, which is not free, but it's also approximately the price of a really expensive textbook. And so it's like a harnessing of this movement of people who are engaged in low volume production anyway, but a shifting of the application from just general fabrication to fabrication where you're integrating electromechanical systems, software with
the AI machine learning and computer vision also added to the system suddenly makes these. This is more than, oh, I can print my own toothbrush or whatever. I mean, this is becoming a whole system. And there's questions from the others. I'll get them right now, because now I'll have another one. The one thing I wanted to ask was that I recently read a very interesting article on OpenMap, which is, open source, people across the world sharing streets and street information, navigation information, very much in the same attitude as the early maker movement, like, okay, let's work together, we can do this, but now being supported, underwritten by some really big companies, the Googles, the Amazons, the Microsofts, because they've created a sort of shared middle ground for everybody to make use of. So it becomes it's the neutral space where people can now build businesses on top of. Is this also happening with this movement? Because I can imagine that what you develop, it's not like you file a patent and the patents will stream towards Nadya Peek. It's like you share this with the whole, the academic world, and then big companies build on top of that.
I mean, I definitely think there is a tension of infrastructure versus application, and when you start working with, a lot of companies have a specific goal, and that goal, they want to achieve that goal before other people. So they need to maintain their competitive advantage, which often means not sharing how they got their results, or not sharing. I often just don't trust those results, or if I can't, this reproducibility crisis also means that, there's a lot of ways in which there's a lot of trickery happening. So first of all, there's some amount of distrust. But then second of all, I think the other problem with that is, on your own, you can only solve problems in one way. You only have your perspective to lean on. And if you're working on infrastructural commons, you have a lot more opportunity to elicit best practices and really get robustness in your system. And so I guess my approach is, first of all, that if you have things that are really, really low cost, then you're going to broaden the participation of who gets to use these systems. And if a lot of people then are getting great results, even in small research groups or even in individually, rather than from big companies, then it's hard to ignore. So that's sort of my plan, is just to like take over from the bottom. But I mean, I do think that there's a place for collaborating and working on a commons for this kind of thing. But the real problem with standards is everybody wants to build and nobody wants to maintain. And so so before you can have a standard, you need to have community agreement on what the best practices are, and we're not really there yet. And so that, I mean, I see a lot of things that need to happen in terms of standards. I think one of the things is in computer-aided design, like everybody is off on their own system. How do we collaborate together on big design projects? I don't know. You can see it now in the response to the COVID-19 supply chain shortages, where lots of people started 3D printing face shields. Maybe you saw, but it's not like everyone made the same face shield. You have the Prusa face shield, Ultimaker face shield. Everybody has their own design, and there is, even in something that is a relatively basic product or a relatively basic set of design constraints, no convergence in the design.
Okay. So there's a lot of ground to. Okay. We'll come back to this. Tamberg, would you like to ask your question on audio, maybe, or video even? Or are you? I cannot always see if somebody has that. Yeah, you can. Would you like to ask your question, Tamberg? Do you listen?
Yeah, I tried to enable video. I'm almost there. Sorry.
No, it's a two-step system. Everybody has to do that all the time.
Thomas, of course.
Hey.
Nadya, you mentioned that you built precise mechanisms from self-made parts that are maybe not that precise. Which principles enable this to do this?
I think that one thing is to use like hobbyist equipment, but you don't necessarily always want to use like hobbyist theory. And so I rely a lot on precision design principles, like precision machine design. One good resource is The Fundamentals of Design by Alexander Slocum. And there's a lot of things like how do you enable error correction? And obviously we have figured this out as humans, because you can start from like an imprecise cast iron base, and then eventually make a lathe, and then eventually make more precision parts, and then make mills. So there is a bootstrapping series of techniques that you can take on. And there, I think you have to think a lot about what is the motion that you want to enable, and how do you constrain motion in the other degrees of freedom. And so the Maxwell coupling, for example, has 3 spheres and 6 cylinders. And so it makes exactly 6 points of contact. And you have 6 degrees of freedom in any moving body. You can move in X and Y and Z, and then you can rotate and roll, pitch and yaw. And so you have exactly 6 points of contact, constrain exactly 6 degrees of freedom. And similarly with when you want to design a flexure, it's a flexure is something that can push on something else. But where are you pushing on the other thing? If you're pushing on a whole plane, then the thing can move the thing can move within that plane. And so if you're trying to make sure that one part matches the other, and you want to match it to that plane, you might only want to have 2 points of contact if you still want it to rotate, or 3 points of contact. And so, yeah, I rely on precision machine design. I think a lot of places where you can also find inspiration for this is in optics. People in optics really need to do they need to precisely align things. And so, yeah, I would encourage like looking more into those places for inspiration, but maybe also things like 3D printing enables you to make like parts that are sort of slightly flexible along with parts that are more rigid. So how can you combine rigid parts with flexible parts by designing in things like live hinges? And then you can do things like if you have a buckle and you want it to align more or less in the middle, then if you click in the buckle, it's like you're using that flexure as an aligning force. So I think people in industry maybe wouldn't always use a buckle, because making a buckle is much more complicated than just like connecting two flat things together with fasteners. But then if you're going to connect two flat things together with fasteners, you have to make sure they're precisely aligned before you actually put the fasteners in. And that precise alignment has to come from something external rather than from the geometry of the parts itself. No.
Cool. Thank you very much.
Yeah.
Dries, you also have a question. I think you're in Africa somewhere, aren't you? Can you switch?
Hello. Yes.
Yeah, there you go.
I'm indeed reporting from a flaky internet connection in Senegal. So happy to be here. Thanks for the talk, Nadya. I wonder, when you show that image of the block-based interface for how people can program their own way of interacting with machines. Maybe I can even like hang on. I wondered what your take or view is on the idea of end-user programming in that context. Like, what's the role of, is it like these interfaces for controlling machines? Is it something that you envision as being still created by a designer or some kind of organization? Or is it something that the people using machines need to make or create themselves? So I was kind of wondering what your take on that is.
I mean, in general, I think one thing that has been an issue with end user programming is this notion of the all-powerful reified designer, and then like these people who just can only like have these seamless experiences and they cannot deviate from what you've imagined as a designer. But I mean, I think if you think about the system and you have a more nuanced view of the people engaging with it. So it's not just users and designers, but maybe there's someone who's doing something over and over again. So you want to use your machine in a particular experiment over and over again, and you want an interface specifically for that. And maybe you're the one designing that, or you're the one designing the interface and someone else is using it, but both of you are working with this system. And so I think what I think of is you want to have lots of different levels of possible engagement. And so if you think about maybe it from like a systems tailoring perspective, maybe I'm just using the system. Maybe I'm changing some parameters of how I use the system. Maybe I'm extending the system. Those are all different modes of engaging. And all of those modes, I think, need to be possible. And sometimes there's a preference to really try to work on just the seamlessness. But in this particular case, I think seamlessness is not useful, because seamlessness relies on a dominant use model, which we don't have. Scientists are all really different. People using machines are all going to be really different. And so I think it's much more important to have robust ways of connecting systems and being able to easily add and remove parts than it is to say, okay, we have to make it as easy as possible for people to do this like data flow programming kind of interface. The one that I showed, it's like it's just for customizing how long. It's like a sonicating wand, and it's just for customizing how long and in which wells the sonicating wand is sonicating.
I could have a follow-up question, but I'm...
Yeah, go ahead.
Yeah, at that point, you are still using a block-based interface to like customize it. So I was kind of wondering, like...
Well, it's the chemical engineer is using the block-based interface to customize only one experiment that was designed by someone else in the lab. And so it's more like for that task, you're using the block-based interface. But if you want to use the machine to do something else, and you remove the sonicating tool and maybe load other tools like a colony picking tool or a camera for computer vision. And then if you want to have one of these simple interfaces like this block-based system, then you need someone who's going to be working on designing a new block for a new tool if you make a new tool. But if you have, for example, already a library of tools and the blocks that correspond to the control of that, then you can start composing within this environment. And so there, I think, you know, I agree with you that the block-based environment is not the only way to engage with the machine. We also like using Jupyter notebooks, for example. But depending on who's going to be actually doing the stuff with the machine, the experience, I think, needs to be tailored. And you can do that maybe partially yourself, and then partially maybe there is a designer who's engaging with that. I guess what I would like is that eventually, that you don't necessarily need a lot of design expertise to do that kind of customization. But I don't think we're totally there yet. I mean, it's still making a new tool and then making a new control block for it. You still need some amount of expertise. But maybe the future will be better.
I actually have a question for you about that future. Let's say, you know, the Bill Gates Foundation says, this Nadya Peek, she has a vision. We need to get there sooner. Here is $1 billion for you. What are you going to do? I mean, what does it take to get from here to where you want to be if the resources are there? You know, if the resource part is no worry anymore, what would you do?
Well, I mean, I think a lot of what I would initially do is work on community building, because right now, a lot of the things that I'm doing with machines, even if I'm doing like super fancy plant growth feedback loop stuff, none of it is impossible. And so there are places where they're doing like crazy automated experiments. It's just not, you know, in words of William Gibson, evenly distributed. And so I guess the thing that I'm really interested in is how do you have how do you lower the threshold so much that lots of people can engage and they actually do engage. It's not just a certain profile of person who's like, oh, I'm really into machines and tinkering and I'm going to like try to figure this out. It's like, oh no, this is actually the easiest way for me to get this done. And yeah, I think that you look at the maker movement.
Education program, because or change the curriculum of existing programs to make people at least aware that these things are, you know, feasible.
Yeah. I think it's both. It's like, I mean, I definitely would continue in system design and system development, but then I also would want to be able to design systems that actually make sense in this context. I would need to engage deeply with people who are actually going to benefit from it, because otherwise you just design things that no one needs. And I think that that's actually it's non-trivial to engage with a really, it's much easier to talk to people who are just like me than it is for me to talk to people who are quite different. So if I'm talking to biologists who don't necessarily have the same mental models of how you would describe a series of steps, not like they maybe don't think of it from this action needs to happen after this action needs to happen after this action, but more from this is the reaction that needs to occur, and after that, this other reaction needs to occur. And so being able to figure out how you can describe both those models of how the world is working in these systems, I think is very important. One of the failures, I think, of the maker movement has been a real lack of diversity. Leah Beakley talks about this a lot, but you see in people engaging with tinkering and 3D printers and Arduino and stuff have a profile that's very much skewed towards wealthier and white and male. Yeah. No shade if you are, but
All right. Are there any other questions from the audience? Because I've got one other question I would like. But, well, I've got about 10 actually, but I want to give them out one by one so that something comes back from the audience as well. You all think the next question. I'll do mine now, and then you are. There's 20 people who come up with a question. With the technology for all kinds of processes was, of course, accelerated immensely, not only this year, but the last few years, and especially on the software side with the computer vision learning and AI and so forth. I mean, what technology area do you yourself find most interesting at this moment? Because your machine sort of connect to a lot of these different areas. I mean, the purpose of the machines and the ways you can use the machines combine different. What is the part where you are most excited or interested in right now?
I mean, I definitely am excited by, I'm gonna say by lots of things. I think that you can do a lot of things with computer vision model. Like there's things. When I was a student at the University of Amsterdam taking computer vision, we could do things like recognize edges and maybe find circles in an image. And a lot of that, you can now take advantage of machine learning techniques to do things like very easily do background subtraction, so you can figure out what the object is that you want to be looking at. And I guess it making that so easy I think that things being really easy makes things exciting, so that it's not actually a big deal for me to then use those models to look at plant growth. And it's not only like a computer vision researcher who would write a paper about that who would employ that, but even my friends who have a design company that makes a lot of puzzles, they use machine learning models like that to help you design your own puzzles. You're like, oh, here's a picture of my cat, and you're only going to look at the cat. So that I think is exciting, like the making of much more accessible of that type of technology. And I think that's also, for example, in hardware. Again, when I was a student at the University of Amsterdam, for part of it at least, Arduino didn't even exist. And now you have things like the ESP32. You can have like Wi-Fi for basically nothing. You can like connect anything to anything for basically free. And there's a lot of things to engineer about, making sure that things are robust and communicate well. But actually adding more to the system it's not trivial, but it's not, it doesn't have the same threshold as it did before. So you can start really be adding a lot more complexity to your system. And that I think also has some drawbacks. Like you don't necessarily have, you still are relying on maybe some backbone technologies that could really use a complete overhaul. Like I still communicate over I2C or serial all the time. And then I'm like, why why is this so, why is this the way that I get this data? But yeah, I don't know, that doesn't necessarily make me sound very excited. I mean, I'm very unexcited about a lot of things too.
Of techniques that were only 5 or 10 years ago completely difficult and hard to understand and are now in everybody's hands, basically.
Yeah.
So at least the understanding is already there. Iskander would like to ask a question. Iskander. It's almost the last question as well, so there you go.
Would you to see the...
Oh no. Yeah, but I maybe I also it's a bit what you were talking about already. So it's maybe a kind of a repeating thing, but I really like to think about it, that how you try to automate this process. You make it easy for the people that can do the robotic thinking or making themselves, but what role do this you were mentioning already a little bit of machine learning things or AI, how will this more intelligent understanding systems, will it be more like a tool that are you creating, or is it more like a boosted humanity or something like, or a partnership? What kind of role does this automation have with the user?
Yeah, I think there has been in the history of AI, there have been two kind of dominant modes of thinking about what that is like. On one hand, you have Marvin Minsky, who's like, oh, we need to have a theory of the mind so we can create an autonomous intelligent agent. And then on the other hand, you have Douglas Engelbart, who is like, no, we want to augment the capabilities of humans. And I'm much more on the Douglas Engelbart side of things, where I deeply believe in humanist value. I really think that people understand and problem solve, and that augmenting that with tools is, at least for things like fabrication or scientific exploration, that's the mode I imagine. So it's not like I want to have Jarvis making me Earl Grey. I want to have lots of tools that help me drill holes exactly where I intend them without having to take lots of measurements. And I think the thing with AI is AI is such an unspecific term, where everyone's like, oh, everything is just smart. Everything can do it. And if you think of it as a technologist or as a designer or as an engineer, then it's not just that you like, oh, here I am in Photoshop, and now I'm going to add some AI. You're like, no, I want to do things like adaptive fill, or there's like very specific tasks that you employ certain machine learning techniques through. And maybe it's for creating voice interfaces, or maybe it's for doing specific image processing tasks, or maybe it's for figuring out smooth robotic motion. And so the thing that I do sometimes get frustrated with is people acting like AI on its own is just going to solve problems. And it's not actually something that's marshaled by people who want to solve problems and are building these tools in that service. And the biggest frustration is that AI is marshaled by people who have goals that aren't necessarily aligned with me, where it's like, oh, how can we extract as much out of this individual who is like seen as a purchaser? So I'm just using these tools, I'm marshaling these tools in service of ad tech. And I'm like, what a waste, what a waste of human ingenuity.
Definitely. I agree, totally agree. Yeah, I put the AI also just between, whatever. But okay, yeah, cool, thanks. I think there's another question maybe, so.
Yeah, there's a lot. I'm going to make that the last question, so then we can round it up. It comes from Nidhi, and we know that she doesn't have to speak, so I'll repeat it. Do you guys think that technology is making our societies monocultural? Will the future of humanity think, feel, and do the same things? I don't know. This sounds like a Friday afternoon gin and tonic question, to be honest. But I'm giving Nadya the first kickoff of this one.
Yeah, I mean, I do think that there is some amount of there's a homogenization for sure in terms of how we engage with each other, and I don't even think that it is a homogenous reality. I think it's like everybody imagines this is the way we should be, and then is trying to get to that. And so, I was in, I think maybe 2010 or a while ago, I was in Lima, Peru. And there you have all of these little markets, or at the time at least, you had all these little markets where you could do things like buy transistors or resistors, or get electronic devices repaired. You could order PCBs. And so Arduino already existed at this point, but wasn't necessarily as widely available as it is now. And in this market, I worked with some friends of mine to figure out how we could build an Arduino, Arduino that was the Arduino functionality, but entirely using parts that were available, parts and services that were available in that market. The market was called Paruro. And so we went to one vendor and had a little PCB made. We used like serial instead of USB with a serial to USB converter. We used a through-hole version of the chip. You know, we had this whole system. And then at the end, you had exactly the same functionality with the same weird pinout of the Arduino. And we were like, cool, this is like a local version of this. The reactions of the students in Peru that we were working with were like, yeah, but this is not the real thing. We want the real thing. And so it's not about, in that situation, it's not about functionality because we had the same functionality, but it's about this homogeny of this is the system we should be using. And yeah, that's concerning also for other kinds of much more complex systems. Should we be using the same insurance estimating systems in like I live in Washington State, in the western part of Washington State versus the eastern part of Washington State? Like, I don't think so. But because of how people think, like how people conceive of correctness of, or the way things should work, I think that often happens. We should all use the same. On the other hand, I also can imagine that there are reasons that you want to argue in the converse. So again, with like the PPE shortage crisis in COVID-19, making lots of different types of protective equipment means that everybody has to be trained different, like putting on and off your face mask or putting off and on your face shields. There maybe diversity is not so great, and instead we need to be able to really reliably trust a standard that we all work towards. But I think that right now, that kind of monocultural design decision is much more hegemonic than it is grassroots. So it's more like, oh, I'm 3M and I say that this is the standard that we should all use, rather than lots of different countries being able to work together to establish what we think is the best practice for protecting people.
Well, let's hope that your adaptable machines for making and configuring and so forth, creativity that should happen at the bottom or at any time, going and growing as well. Yeah. Thank you so much.
Yeah, totally. Good to see all of you, sort of see all of you.
Yeah. Well, thank you again for joining us. It was a wonderful conversation and talk. So, how do you say this? I'm really proud of you. This wonk thing, I admire what you do. Keep doing it.
Thank you. Thank you.